Section 1.5, example 2. This example involving a trigonometric function, sine. So let's okay, this one. Yes, this limit, of course. In this part, our textbook suggests you will use a calculator to input some data, theta, to observe the value and guess the, make a conjecture of the result. We will explain this limit is 1. This limit is 1. Okay. First of all, I would like to claim when theta is nearby 0, but nearby means maybe in this bound, in this bound. In this case, we have sine theta. Is less than the absolute value of theta and less than the absolute value of tangent theta. Okay, claim this one. Why? Let's consider two cases. If theta is okay, I will fill the blank later. A. We consider two cases. One, when theta is positive, but is less than half pi. In this case, theta may be anywhere of this arc. For example, here, so we have theta. If theta is negative, theta may be here, maybe anywhere of this arc. In this case, theta is positive because this angle is rotate from this initial side to the terminal side counterclockwise. Here, the orientation is clockwise. So this theta is negative. Let this be the origin, right? And this point be A. And at this point be P. Consider a tangent here. So in this case, we can express the quantities in terms of some geometric, the measurement of geometric objects. For example, the length of this one is sine theta. And the length of this one is cosine. And the length of this one is, of course, 1. Okay, because these two right triangles are similar, so the ratios are the same. The ratio of sine theta to cosine theta equals the length of this one to 1. But the ratio of sine to cosine is tangent. So this is 1 and this is tangent. Yes, this is the quotient relation. Tangent equals sine over cosine. This one over this one is tangent equals sine over cosine. Similarly, we have the length of this one, because by definition, the coordinates of this one is cosine theta, sine theta, so this is minus sine, or we can put an absolute value here. Cosine. And also, the coordinates of this one is 1 tangent theta. So the length of this one is the absolute value of tangent theta. Now let's compare the areas of this triangle. Triangle AOP and the circular sector AOP and the triangle AOQ, for example, Q. Let this point, the name of this point be Q. So we have the area of AOP is less than the area of the circular sector AOP, and it's less than the area of the triangle AOQ. And of course they are positive, all positive. The area of this triangle AOP is of course the base times the height. The base is 1. The area of AOP, triangle AOP, is the base times the height. Base, height. 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 Base, height. The area of this circular sector is 1/2 r squared theta. But here, theta is positive. Theta is exactly the upland of this one. But here, theta is negative, but whose absolute value? Absolute value. Absolute value of this one is exact the length of this arc. Okay. Also, 1/2 times now base is 1. Height is tangent. But for theta is negative, tangent is also negative because tangent is the y coordinates on the lower half plane. Lower half plane is negative. We put an absolute value here. So we obtain 0 is less than sine theta, less than the absolute theta, and less than tangent. Of course, when the theta is in this interval 0 to half pi, we don't need to put the absolute value notations here. Okay. So sometimes someone will wonder, this is trigonometric function. This is an angle. How can we compare with this? It seems two different kinds of quantities. In fact, they are all real numbers. Okay, all real numbers. Besides operations, we have two relations. One is the order means it's less than. Another one is equal, less than or equal to. So this proves the first statement here in this condition, under that condition. Okay. Now we consider their reciprocal. Their reciprocal. Then we have wait a minute. Divided by sine. Divided by sine, then this will be 1. Okay. Divided by 1, because this is non-zero, a positive number. But we won't find this limit, so we consider the reciprocal. Okay. Reciprocal. If two numbers, the large one whose reciprocal will be the smaller one. Okay. And why we can remove the absolute value? Because when theta is positive, sine is also positive. When theta is negative, sine is also negative because the codon of P this is positive, but this one is negative. Sign is negative. When theta is negative, sign is negative. Negative and negative become positive. It's positive. I think this one will be enough, huh? Okay. From this we have because no matter theta is positive or negative when it's small, I mean close, nearby, near is near to theta near to 0. Cosine. Cosine here, positive. Cosine here is also positive. So we can remove the absolute value. And similarly, if theta is positive, sine theta is also positive. If theta is negative, sine is also negative. In the first and the fourth quadrant. First quadrant, second quadrant, third quadrant, and the fourth quadrant. When the theta in the first and the fourth quadrant, cosine is positive. Okay. So also we have therefore, by squeeze theorem, the middle one this one. I think you still remember this. Trigonometric functions no matter where A is. This is A. And this is X. Okay, if this is the unit circle, then the coordinate of this point will be cosine A. Sine A. And the coordinates of this point is R cosine X, sine X. When X approaches A, means X close to here, or maybe from this direction or this direction. As you can see, the projection, this is cosine A. This is cosine X. Okay. So when X approaches A, cosine X, whose value is cosine A? Cosine A. So if we want to evaluate the limit of 6 trigonometric functions, you can obtain the value by direct substitution, by letting X be this number A. Okay, so here, cosine theta approaches to 0, cosine theta will be cosine 0 by letting theta be 0. And the cosine 0 is here, 1. That's the reason why here is 1. Because we can find this value by direct substitution, by letting theta be 0. Cosine 0 is 1. Okay? So, if a number is strictly less than another one, then automatically this is necessary condition. Okay, this necessary condition. So this form, these two conditions are exactly the conditions in the squeeze theorem. So applying the squeeze theorem, we obtain the middle one whose limit is the common limit of 1. Okay? So when we evaluate cosine or sine or tangent or cotangent in this domain, we always can obtain their limit by direct substitution. By direct substitution. Very good. So here you should realize this x may be u-axis, v-axis, because we already use x to describe the angle. Okay. Good. So we already solved example 2 because this example involving trigonometric function. Good. This is a very important, a very famous limit. So please remember, memorize this. The consequence of this one is Okay, we have seen this just now here. Next, and let me explain this one. Okay, simplify this expression. We have cosine squared theta minus 1. This is theta times cosine theta minus 1. Since the sum of the squares of sine and cosine is 1, the numerator is minus sine squared of theta. Sorry, this is a plus sign. Well, I told you this is the consequence of this one, or direct consequence of this one. Why? Because in order to use this result, rewrite this expression in this form. Okay. Since this limit exists as z approaches 0, this is 1, then the quotient, the limit of this quotient, because when theta approaches to 0, this is a polynomial in theta. So this is 0. Oh, 0 is good. And this, we can obtain this by direct substitution. Cosine 0 is 1. Therefore, here. 1 squared times minus 0, 1 plus cosine 0. And the cosine 0 is 1. Zero, okay? So this is 0. All of this will be used in the future. Will be used in the future. I mean, there's two important limits, two important limits. When we deal with the differentiation of trigonometric functions, the first we will encounter this one. Encounter this one. Okay. Let me see what the next example involving trigonometric functions. Oh, example 3.